Alright everyone, today we are going to learn how to represent g of n equals 45 times 2 to the n minus 1 power, which is the explicit form of a geometric sequence. And we're going to basically change that into a function form, which looks like f of x equals some number a times some number b to the x power. Okay, so this is geometric sequence right here. And this is function form. And let me be more specific, it's explicit formula. Okay, so it's not too hard to do. Move my microphone. It's not too hard to do. So we're gonna start by just writing out what we have, okay? G of n equals 45 times 2 n minus 1, and f of n, which is the function notation, 45 times 2 n minus 1. Okay, so we're going to rewrite this one here. 45 times 2 n minus 1. And using the rules of exponents, we can rewrite this. It's the product rule of powers as 45 times 2 to the n times 2 to the negative first power. Okay, I did nothing special. All I did was rewrite the all I did was rewrite this here. Okay, the 2 to the n minus 1. Now I'm going to go ahead and take this here. We can also rewrite that. 2 to the negative 1 is the same as 1 over 2. So let's go ahead and rewrite that. 45 times 2 to the n times 1 over 2. Okay. Again, I did nothing special. All I did was to show you. I focused here. I rewrote it here and here. And then now I just focused just on the 2 to the negative 1 and rewrote it as 1 over 2. Okay. Now, as you know, I can rearrange these here, right? So an example is like 1 times 2 times 3 is 6. Just like 2 times 3 times 1 is 6. Just like 3 times 2 times 1 is 6. You can move them around. That's a commutative property. And so order doesn't matter in terms of multiplication. So let's go ahead and rearrange some of these. And the reason I'm going to rearrange them, let me just rearrange them first. 45 times 1/2 times 2n is so that I can combine those two right there. Remember that 45 has a 1 under it, and we multiply across. 45 times 1 is 45. 1 times 2 is 2. And then I'm going to bring, let me go back. I'm going to bring the 2 to the n. I'm just going to bring it down. Okay. And I think we might be done. So, how do we know we're done? Look at the function form. Some number a times some number b to the x power. Some number a times some number b to the x power. X and n, you can change it as you please. So we're basically done already. So I'm going to rewrite the whole thing. We don't need that. So G sub n equals 45 times 2n minus 1, written in function notation is all, whoa, what did I do? Is all of this right here. F of n equals 45 over 2 times 2n. And you can approximate the 45 over 2 if you want. I'd rather have the exact answer, but that's on you. 45 over 2. And right here, that's an A plus answer right there. So just to recap kind of what we did. We have the explicit form of a geometric sequence right here. And we want to turn it into function form right there. So that it looks like a some number a times some number b to the x power. B x power. Okay? I just rewrote them again right here next to each other. But then I took this function form and I just started working with the numbers right here. I did 45 times 2 to the n minus 1. And then I went ahead and I broke it up each step. 1, 2, 3, 4. And there we go. That's my final answer right here. And then I want to get an A plus, so I just rewrote the whole thing. I took this here and I rewrote it here. Actually, what I should have done, well, yeah, same thing. But I'll erase this, and I'll go ahead and put the new thing we got. 45 over 2 to n. So this shows what we started with, the geometric sequence, the geometric formula, and then that same formula in a function form or function notation. Okay? And then I wrote it out. Cool. So I hope this was helpful. Let me know if it wasn't, and I'll help you out. That's it. Peace.